Hello, we are going to do a quick video on lesson 28, the product of powers exponent property. So let me share with you a screen. Let's go here. So these are the notes that you have in your Google Classroom. And if you look at the learning target with me, we are simplifying expressions using product of powers exponent property. So some vocab, first of all, if you talk about this whole thing here, that would be called a power. It's got parts. It's got an exponent, which is the 4, and it's got a base, which is the number that sits down below, which is in this case the 2. And what this means is 2 times 2 times 2 times 2. It means you have 4 copies of a 2 multiplied together. That's what that would mean. Okay, and now to the property. So this is the product of powers property. And so the word product means multiply. Powers, we said that is kind of anything that's written with a base and an exponent. So what this translates to, product of powers, means things written as powers that are multiplied together. That's what product of powers is. Things written as powers that are multiplied together. Now, here in the box, it says for any number A. So A is a number. It could be a 2, it could be a 10. It's a number. Sometimes we don't know what number it is, and we'll call it a variable. We may call it X. But that part is a number. For that and for all integers m and n. And so if you see the word integers right here and don't know what that is, all the counting numbers, like all the whole numbers starting with 0, all these counting numbers and their opposites, those are integers. So any number that's 0, 1, 2, 3, 4, or -1, -2, -3, -4, those are integers. So m and n, the exponents, are going to be those counting numbers and the negatives of them. So when you have a setup like that, which is going to be most everything you're going to see that is written in this form, if you have the same base, so the A has to be the same number in both cases, what you get to do is you get to add their exponents together. So like A times A to the m times A to the n would be, add the m and the n together, it would be A to that new number of the 2 previous exponents added together. Here are a couple examples, okay? This first example right here, you have 3 squared, you have 3 cubed. Since the 3 base, the bottom 3, is the same, you get to add the exponents. And so here you see 2 plus 3, that's the exponents being added together, which gets you a new exponent of 5. Now, if you break this thing down to the definition of exponents, let's look at that off on the side here. 3 squared times 3 to the 3. If you go down to the definition of exponents, 3 squared means 3 times 3. 3 cubed, I'll put it in a parenthesis. 3 cubed means 3 times 3 times 3. Now, the parentheses and the dots, all that is multiplication. So if you add up and use the definition of exponents and add up how many 3's are being multiplied together, there's 1, 2, 3, 4, 5 of them. And so to write it as an exponent, it would be a base 3 with 5 copies all multiplied together if you just counted up how many 3's there were. And you can always go down to the definition of an exponent. Take the 3 squared, expand it to 2 3's. Take the 3 cubed, expand it to 3 3's. Count how many there are. There's 5 of them. And that is the new exponent on your base. Now, we said it also works with variables. So looking at the next example, here we don't know what x is, but as long as we have x, it's always the same thing. So if I see another x, I know it's still the same thing. So x squared times x to the 4th, since the bases are the same, the x part is the same, I can add my exponents. And so that's the 2 plus the 4. 2 plus 4 makes 6. And so the new exponent is 6. Now, if you look at that and appeal to the definition of exponents, x squared times x to the 4th. X squared means 2 copies of x multiplied together. X to the 4 means 4 copies of x multiplied together. If we counted those all up, we have 1, 2, 3, 4, 5, 6 of them total counted up. So these written as an exponent would be 6 copies of an x all multiplied together. And that's another way to see how that would come out to be x to the 6th. Okay, so that's the basics. Let's go look at a couple problems. We will use your worksheet. We'll use ones that aren't part of the worksheet that you're going to do for the assignment, but we'll use the other problems, the odd numbered problems. So let me get to the right screen for that. All right, so here is your exponent worksheet, and you're doing the evens on this. Let's go through and do a few of the odds. Like here you have on number 1, let me turn on my drawing tools here. Well, hold on, I think I can do this the way I would like to do this. Let me do it this way. All right, so number 1 right here, you have 4 squared times 4 to the 2nd again, 4 squared times 4 squared. As long as the bases are the same, and they are, the 4 and the 4, you can say that this equals that same base and take the first exponent plus the second exponent. And when you're all done, you would have a new exponent. In this case, it would be a 4. And so that is another example just with some numbers. Let's jump down and look at, say, for instance, number 7. If we were looking at number 7, you could rearrange these a little bit. There aren't any exponents on the coefficients. So for instance, 2n to the 4th, that exponent 4 only is working on the n. So the 2 is out in front and it's multiplying. And then there are 4 copies of an n. 1, 2, 3, 4. That's what 2n to the 4th means. Now, think about how that's different than 2n to the 4th like this with an x with a parentheses around it. If it had parentheses around it, then you'd have 4 copies of 2n. You'd have a 2n, a 2n, a 2n, and a 2n. That would be where the 2 got repeated 4 times and the n got repeated 4 times. So this one doesn't have those parentheses. And so this one isn't the same as, oh, let me try to do something here and move this. This isn't the same as if it were the kind there that I was just showing you. All right, so ours is not like this. Ours doesn't have those parentheses. So here's what you do. You remember with multiplying, it doesn't matter what order they come in. So I can take and reorganize my multiplying. This is where I'm finally working the problem. I can put the 2 first, and then I can say times the 6 from the other number part. And I can then say n squared times n to the 4th and put the 2 n powers beside each other. Then I can do some simplifying with the 2 and the 6. I can multiply them together and get 12. And now I can add my exponents. The exponent is 2 and 4, add them together, and that makes 6. And that's the new exponent on the n. So you're using the properties where you can reorder multiplication, just like this idea here. 2 times 3 is the same thing as 3 times 2. They're both 6. It doesn't matter which one was first. And that's how we get away with reorganizing things that are multiplied, that property. All right, I will do another. Let me go down a little further. And anytime you can slow the video down, you can pause and go back. So if something needs to be looked at again, go ahead and go back and look at it again. Let's look at something like how about something wild like number 13? So on number 13, we'll be working right here. We would have a reorganization of this. We want to group things together. So we want the numbers grouped together. So the 7, the 10, the 8, those all get grouped together. Now let's get all the u variables. We'll go alphabetical. So u comes first. So the u variable, the first u variable I see right here is u to the third. And then there's one other u variable right there, which is u, and it doesn't have a power. That means there's a 1 up there. Because if you have an x, that's the same as x to the 1. Now, let's go through and collect all the v variables. So coming from left to right, the first one is v cubed. So that's the first one. Then I see a v to the 5th. That's the next one. And then on the end, I see a v to the 3rd. And that's the last of the v's. So now we're simplifying. So we're going to have 7 times 10 times 8. Now, you can go get a calculator, or if you do 7 times 8, that's 56. And then times 10, that's 560. You can check my work with a calculator. That's all the number part. So I did all the number part together. Now I'm going to do all the u part together. Since they have the same base, I can add their exponents. So we can add the exponent 3 plus 1 and get u to the 4th. And make my 4 look better. That's the power on the u. And now I'm going to do all my v variables together. They all have the same base. And so I can add all these exponents together. So 3 plus 5 is 8, and 8 plus 3 more is 11. That would be v to the 11th. And this would be my solution simplified. 560 multiplied by u to the 4th times v to the 11. Okay, so those are some examples, and I hope that you are awesome at this. I know you will be. Just takes a little bit of practice. So I will see you later.